So in this session, we're going to focus on building machine learning pipelines. And we'll see that there are a number of ways to do this on AWS. But first, let's define the problem. Why do we even need to focus on this? So in real life, you need more than a single model to predict. Okay? In many applications, life is not as easy as load the data, send it to the model, get the prediction, and do it again. A lot of times, you will need to pre-process the data. So you need to do normalization. You need to do feature engineering before you can actually predict. Okay? You need to maybe load data from a backend to complete whatever data you received on your API, et cetera, et cetera. So the data that you receive is not enough. It's not ready to be predicted immediately. And you may also need to do post-processing. So if you're classifying images and you have 1,000 classes, you don't want to return 1,000 probabilities to the caller. You want to return maybe the top 5 or the top 1. You may need to sort the data, et cetera, et cetera. So there's probably some extra work that needs to be done after predicting. So what we're going to do is we're going to try to build ML pipelines with minimal infrastructure drama, because infrastructure just gets in the way, and we want to do machine learning. So we're going to use managed services like Amazon EMR, and I'm going to focus on Spark and Spark ML. So first, we'll try Spark on its own, and then we'll try to combine Spark and SageMaker, and we'll discuss why I think this is a good idea. And then we'll see how to build pipelines with multiple models that are chained strictly using SageMaker. So let's start with Spark. So who's using Spark today? Okay, quite a few people. So just a quick reminder of what Spark is for the folks who are not familiar with Spark. So Spark is, I like it. That's important. It's an open source distributed processing system, and it was built to improve on Hadoop. So Hadoop was nice and interesting in its time, but it was painfully slow. So the number one goal of the Spark project was to make everything faster, much faster, right? About 100 times faster than MapReduce, by loading everything in memory, loading the data in memory, running all the transformations in memory, and making extensive use of caching. So avoiding unnecessary computation by caching intermediate results, etc. And this is how Spark is blazingly fast. It can do a number of things. It can do batch processing, just like Hadoop did, but it can do streaming. It can do machine learning, which is what we're interested in today. It can do graph databases, and you can even query using some form of SQL language. And last but not least, you have APIs in different languages, but I will use Python today. So the central concept in Spark is the DataFrame. So a DataFrame is a distributed collection of data. Distributed because Spark is a cluster system, okay? So we work with multiple nodes that collaborate in computing data. And we distribute data sets over the different nodes. And those data sets are organized in named columns. So you can really see a data frame as the equivalent, and I will put quotes around that, of a relational table, right? A table in a relational database. It looks the same. It's obviously different in the sense that it is distributed by, it's distributed on multiple nodes and it's organized differently, but the way you interact with it is very similar to a database. And the DataFrame API is very convenient. You can load all kinds of data formats, so text files, JSON files, etc., CSV files, columnar formats, and so on. You can support all kinds of files, Parquet, Orc, etc., etc. So chances are, there is a built-in loader for the format that you use. So let's say I have a JSON file, okay, with names and ages. And Jeff is Jeff Barr, and you don't ask Jeff Barr how old is he. Yeah. So Boaz is 72 years old, as we all know, and I'm 12, sometimes 8. Okay. And if I read this JSON document just like this, and I display it, this is what I see. So this is very similar to a table. Okay. And it doesn't have to be really, really complicated. So the DataFrame API is really convenient. Spark has a machine learning library. Oh my God, we have birds. It's called MLlib. So as you would expect, it has a collection of algorithms. And I'm going to say a very nice collection of algorithms. Plenty of different things like classification, regression, clustering, collaborative filtering, with plenty of variations. And it's one of the better machine learning collection of algos out there. It has an API for featureization, so transforming data, feature extraction, transformation, dimensionality reduction, etc. And we'll use some of them to pre-process our data. And very interestingly, it supports machine learning pipelines. So it has the ability to chain different processing steps, okay? And those steps can either be a transformer. So a transformer transforms a data frame in another data frame. So again, this is really about what feature engineering is about. Or it can be an estimator. So an estimator will predict a result based on a data frame. Okay, so you can build pipelines by combining those two types of steps. Okay, and we'll see an example in a second. So when you train a model on Spark, it gets trained on the cluster, and then obviously you want to predict with it. So the first option is to just do it in the same app, right? In the same Spark app that you've trained and loaded the data in and trained the model in. You can just take your model and call the prediction API, pass some data to it, some data frame to it, and get an output data frame. Okay? We'll see an example in a second. Or of course you can save the model and in Spark and load it in another Spark application later on. Why not? You can export it. There's an export format called PMML that lets you use a model with other languages like Java, R, etc. Or, and that's the more recent option, and that's the one we'll look at, you can export the model to a format called MLeap. And this is a format that's interoperable with scikit-learn and TensorFlow. And once you've exported the model, then you can load it using the MLeap API, and you can serve predictions. The good thing about MLeap is it's completely independent from Spark, okay? Because in the first two options, you're predicting in the Spark app, in the Spark context. And it's fair to say there's a bit of overhead involved, and it's very difficult to get low latency predictions inside a Spark app. And so that's one of the problems that MLeap is trying to solve. Okay, you don't need a Spark cluster, and you don't pay the Spark tax, so to speak, on your predictions. Okay, but in any case, if you want to do all of this, you still need EC2 instances or EMR clusters or Docker containers, any compute technology that you like to do all of this. Okay, so you still need to do infrastructure, and well, that's not what I want to do today. That's generally not what I want to do. I want to do machine learning. So here's a very simple example of building a pipeline. Okay, so let's say I want to classify text sentences. So my data set would be a set of samples with an ID, the text itself, and a label. Okay, we could use this to build a spam detector or sentiment analysis application, let's say. Okay, so let's say I've got some data lying around. It doesn't really matter which format it's in, as long as I can read it in a data frame. So I would use the DataFrame API to load it. And then I would build a simple pipeline with 3 steps. So first, a tokenizer that would remove the words, replace the words with integers, okay, because machine learning wants numbers, it doesn't want text, okay? And I'll use the tokenizer object to do that. Then the hashing transform, which will bucket those words, because maybe my vocabulary is 50,000 words, and I don't need 50,000 words to train this model. So maybe I want to bucket in 1,000 features, okay? So I'm going to hash my words into buckets. Okay, that's the hashing TF object. And then once I have that, I'm going to train logistic regression, so a binary classifier on that data set. Okay, so 3 steps. Get rid of the text, bucket the different tokens into a number of buckets, and then train a binary classifier on those samples. Okay? And then I can combine them in a pipeline, just like you see, right? New pipeline, set stages, and then add my pipeline objects in the right order. And then call fit to train, okay? And then load some test data and predict it. Okay, so this is a really basic vanilla example of building a pipeline. But that's how you would do this in Spark ML. Okay, using different objects, doing some transform. So obviously tokenizer is a transformer, hashing TF is a transformer, and logistic regression is an estimator. Okay. So let's look at another example. So here, I'm going to use PySpark. So this is a SageMaker notebook connected to an EMR cluster. Okay, there's a bit of a setup phase to do this. And what I want to do is I want to use a data set which is called the abalone data set. So the abalone is a kind of shellfish, not selfish, shellfish, okay? And based on measurements, right, based on information that we gathered on different types of abalone, we want to predict the age of a given I'm not going to say it, shellfish, okay? So this is a standard data set. You probably have seen this before. So I'm going to define the schema for this. So I've got that information in the data set. So I've got you can see it here as well in the bottom. It's maybe easier. So you can see the sex. So you have male, female, and infant samples. You have a feature for the length, the diameter, the height, the whole weight, the shucked weight, viscera weight, enjoy, shell weight, right, and the number of rings that are visible on the shell. And the number of rings is actually an indicator of the age. Okay, so that's what the data set looks like. So I'm starting by defining the schema for that data, okay? And then I'm using the DataFrame API to read the CSV file from S3, storing the data, displaying a few lines, and then splitting the data set 80%, 20% for training and validation, okay? So next, I need to do some feature engineering, because you can see that sex variable is a categorical variable, and I don't want that. I can't use those M, F, or I values. I need proper categories. And the rest are just numerical values, so they're pretty reasonable. So the only feature engineering that I'm going to do here is I'm going to first use a string indexer to replace M, F, or I in the first column with a category numbers. So my guess would be 0, 1, and 2, but don't trust me on that. And then the second step is a one-hot encoder, where I'm going to replace 0, 1, and 2 with a bit field with 3 values, okay? So maybe M will correspond to 1, 0, 0, and F to 0, 1, 0, and I to 0, 0, 1. Okay? And this is how you deal with categorical variables. You want to build different dimensions. So first you remove strings and replace them with integers, and then you replace integers with bit fields, setting the right bit to 1. Okay? And then I can leave everything else untouched. Those numerical features here are fine. So I use a vector assembler to just append the fixed sex, or the modified sex feature to the numerical features. Okay? Very simple stuff. Okay, and then here, I'm going to train a random forest classifier. Okay, so the feature I want to predict is the number of rings. Okay, because again, this is an indicator of the age, and I'm giving some hyperparameters, depth, number of trees, etc. And then I can build my pipeline just like we saw. Okay, so again, indexing the sex feature, encoding the sex feature, assembling the engineered sex feature to the numerical features, and training the model. Okay, so another example of a pipeline, calling fit to train, and then I can take my validation set, I can process that with the model that I trained and show some results. Okay, so the prediction for the the first 5 samples in the validation set is visible here. Okay, so SparkML, very easy. Combine transformer steps with an estimator and do some predictions. Okay, so you can do this on your laptop. You can do this on EMR. It's Spark, and it runs in a lot of different places. Now let's see why we would want to combine Spark and SageMaker. So we've talked about SageMaker a lot, so I'm just going to state the obvious here. So it's a fully managed machine learning service. It's backed by an SDK that lets you train and deploy models on fully managed infrastructure, and we can do other things like hyperparameter optimizations, et cetera, et cetera. Okay, so it's your friendly neighborhood managed machine learning service. So how does it fit with Spark? Well, there's an extra SDK on top of the SageMaker SDK in Python. There's a specific SDK for Spark, okay, and it's available in Python and Scala. Okay, it's pre-installed on EMR 5.11 and up, so it is available on your EMR clusters. But if you have an in-house Scala cluster, just go pip, well, no, not pip, because it's not Python. Just add the right dependency, Maven dependency or whatever, and install that. And the core feature here is now with this SDK from your Spark application, okay? So from your Python, your PySpark code or your Scala code, you can call SageMaker APIs, okay? So you can just load data and train with the either a built-in algo in SageMaker or maybe the TensorFlow container in SageMaker. And you can also add SageMaker steps in Spark pipelines. Okay, so similar to what we've seen, except some of these steps will run on SageMaker. And the best thing about it, right, what really sold me here is there is no data conversion, right? You work with data frames. Load data in a data frame, pass the data frame to a SageMaker estimator. It's going to convert it to whatever format the SageMaker algo needs, which most of the time is protobuf. When you predict with that model, again, it's going to convert to protobuf and back, and you never have to mess with that. And yes, the crowd goes wild or should go wild because this data conversion in SageMaker is not always so obvious. So here, we're completely free of that. So why would you want to do that? Okay, that's the number one question that I get. Why should I use those two services together? So in my opinion, the first and the main reason is Spark is mostly about ETL. So yes, it can do machine learning, but it can't do all of machine learning. So why don't we use Spark for what's its best, which is ETL, and why don't we use SageMaker for what's its best, which is machine learning, okay? And imagine building clusters for Spark and clusters for machine learning, clusters for ETL and clusters for machine learning. You can't pick the right instance type, right? ETL needs a lot of memory. It generally doesn't need a ton of compute. You need a ton of memory because Spark is all in memory. So maybe you need R4 instances. And maybe you want to train a deep learning model. Okay, so you need GPUs. So why not P3? And maybe you want to predict. You don't need GPUs to predict. So maybe you want to use C5. Okay, so that would be the ideal world. But if you work on a Spark cluster, you have to stick to one instance type. Okay. And again, sizing and scaling could be different. You could need, a lot of nodes for ETL and just a few nodes for training. So you would probably size your cluster by default and saying, okay, I need a lot of nodes for one of those two things, so okay, I'll stick to that. But then one of those processes would actually be wasteful because you would train on a very large cluster while you don't need that. So you could save money by maybe shrinking it. And yes, you can resize EMR clusters, but who loves doing that? Right, that's what I thought. And another reason is you could ETL once and train a lot. So maybe you just need the Spark cluster to ETL for a few hours, and then you can shut it down, and maybe then you're going to train for 100 models in 3 days. So again, different requirements. The other reason is SparkML is great. I like it very much, but it doesn't do everything, okay? You may need algorithms that are not available there. And specifically, you may need deep learning, okay, which is not available in SparkML. Or you may need your own custom code in any language, right? Maybe your training code is not written in PySpark or in Scala, right? So you would love to do ETL on Spark, but then you can't really do training in there. And the last reason is probably, something I mentioned before, getting the best prediction performance. Okay, and you definitely want to run prediction outside of Spark. Because like I've said, if you run prediction inside the Spark context, you pay the tax, right? And you need a running cluster, first of all, and you get the overhead of Spark on your predictions. So that's not really good. Plus, we saw that we can export Spark models to the mLeap format, and SageMaker knows how to load those. So there's something here, okay? So low latency, again, inside of Spark is difficult. With SageMaker, just size your instances and scale your prediction infrastructure as much as you want to get to the right level of performance. So some examples, okay? So maybe you can do, data preparation and feature engineering on Spark, and then train on SageMaker, okay, at scale. Maybe you have an existing model that expects certain features, okay, and it works well, but you have to use it with data that doesn't fit inside the model, okay? So maybe you want to transform the data to do feature engineering on your data set so that it can be used for prediction, okay? It's called model reuse, okay? Reusing a model with data that is slightly different. But if you can feature engineer the data to fit that model, then fine, okay? You could try using predictions to do data cleaning or data enrichment. Typically, when we have to add missing values, we take median or we take default values. But if you have clean data, that you could train a model that knows how to predict a specific attribute. And you could probably use that model to predict missing values based on the other features. Why not? Okay, so that's an interesting thing. Or you could use an external model to add more predicted features. So all that stuff could happen during ETL. So while you're doing ETL on Spark, you could invoke models in SageMaker to help with the ETL process. Okay, and generally, if you want to deploy at scale, large scale, I don't think deploying on a Spark cluster is the right way. Okay, shoot me. So let's look at a couple of examples. So the first one I want to show you, is that too small? Yes, probably. Can you see in the back? Or is, yeah? Is that okay? Anyone alive? Yeah? Okay, thanks. So here, I'm using Zeppelin, which is another notebook app, and I'm running Scala code on an EMR cluster. Okay, so this is running on an EMR cluster in Spark. Okay. So what I'm going to do here, this time I'm going to work with another data set, which you've seen before. It's called MNIST. Are you tired of it? Yes, me too. So 70,000 digits, okay? And the game is to predict the right class from 0 to 9 for each image, okay? So as you would expect, I'm reading the data set. It's in S3, so I can read the training set, the validation set, okay? Load that into Spark. And these, as you can see, these have 784 features, which sounds weird. But again, as mentioned in the previous talk, those are 28 by 28 pixel images that we flatten to 784 bytes. Okay, 28 by 28 is 784, trust me. So each of those samples is actually an array of 784 bytes. Okay, so here I want to train. I want to train a clustering model. Okay, I would like to see if k-means, the k-means clustering algo, is able to cluster those samples into 10 clusters, representing the 10 classes. Okay. But 784 features, that sounds like too many, right, for k-means to do its job. So first, I'm going to use the PCA algo to reduce the number of dimensions from 784 to 50, which is just an arbitrary number. Okay? So I'm configuring a PCA transformer, saying, well, using the features column and building a new column called projected features, please engineer 50 new features, okay? So that's my first step, and this is running on Spark on the EMR cluster. And then the next step is just training k-means on SageMaker and deploying k-means on SageMaker, okay? And using that SageMaker SDK for Spark, I ask k-means to take the projected features and build me 10 clusters, okay? So that's my second step of the pipeline. And this will not run on the EMR cluster. This will run on SageMaker, okay? Then I create my pipeline, okay? At the stages, so PCA, right? Feature engineering first, and then clustering next. I call fit, so it runs for a few minutes, okay? And as you can see, I don't worry about data format. I pass my data frames that I loaded. And then I can transform, using the model that I trained, I can transform my test data, okay? And we could even maybe go crazy and try to click on this. Okay, so now this is running on my EMR cluster. Okay, so it's predicting all those samples. And it should show me in a few seconds the predicted cluster for each of the samples. Okay, so I see the original features here, the 784 features. I see the projected features, so the ones that have been computed by PCA. And then I see each cluster, okay, to which cluster each sample belongs, okay, or which one it's closest to, okay? So if you're curious about is this accurate or not, absolutely not. It doesn't work at all. Okay, it does a terrible job. So clustering images with k-means here doesn't really work. But what does work is building the pipeline with EMR steps and SageMaker steps using the same API and never worrying about managing SageMaker infrastructure, never worrying about transforming data, right? If you use Spark ML today, it's very easy to integrate this in your routine, okay? So that's the first example, sorry. So now, let's move back to our abalone example, okay? To the shellfish example. So what we've done here, remember, is we trained a model on Spark, okay? Now, could we deploy this on SageMaker? So let's see how that works. So what I'm going to do here is I'm going to export the model, the Spark model that I trained. I'm going to export it to that mleap format, okay? So just serialize it, convert it into a tar JZ format, which is what SageMaker expects for deployment. Upload the serialized model to S3, okay? And then, okay, it's just another SageMaker model. So I can import it to SageMaker. Okay, I need to define, so let me show you how to do it first. Okay, so you just use that Spark ML model object from the SDK, passing the location of the mleap bundle in S3, okay, a name for the model, and a schema, which is what you saw before. I have to describe the schema of the data that model can take, okay? So that's the JSON, and I can pass this as an environment variable. And this is pretty much what we've seen before, right? Just listing the features and providing a type, okay? And the output should be a float, well, a double representing the prediction, okay? So this is all it takes. Export the model in mleap format, import it in SageMaker, and then I can just call deploy, like we do all the time, model.deploy, and now I have this Spark model being served by SageMaker. Okay, so I can shut down my EMR cluster, and I can get the job done. Okay, and I can invoke it just like I would invoke any model. So take a payload. Okay, so try to predict the number of rings for a female abalone with those features out there. Okay, this line. Okay, and then just call predict, and okay, this abalone should have 11 rings, pretty much. That's what it says. Okay, so you can see it's very easy to export models from Spark and deploy them on SageMaker. Okay, and now, of course, we could be using the instance type that we want. We could use auto-scaling on that endpoint. We're completely free from the Spark environment. So we can take the best choices for the best performance in this prediction task. Okay, so here are the two scenarios. Okay, load some data on Spark, ETL it, invoke the Spark SDK for SageMaker to train, and keep predicting inside the Spark app. Okay, or you could ETL and train on Spark, export your model to mleap, and deploy it on SageMaker just like any other model. Okay? All right, there's one more thing we need to cover. Can we do pipelines in SageMaker only, right? Because we've used Spark so far. What if we don't have to use Spark? How do we train a sequence of models, right, that are needed to get from raw data to engineered data to predicted result? And how can we deploy that? Okay, and it's a newer feature in SageMaker. It came out at reInvent in December, and it's called Inference pipelines. Okay, and it's maybe one of the obscure features in there. So let's talk about it. So an inference pipeline is a sequence of 2 to 5 models, okay, that are involved in a single prediction workflow. So you can use scikit-learn models you can for feature engineering. You can use Spark ML models, okay, just like the one that we've seen before. And you can combine them with, of course, SageMaker models, built-in algos, or TensorFlow, deep learning libraries, etc., etc. Okay, or even your own custom container. Okay, so you can use existing transformers in scikit-learn or Spark ML, and then predict with your own model. And the cool thing about it is, it's a single unit. So when you deploy that to the endpoint, the whole sequence, the whole pipeline is deployed as a unit to a single endpoint. Okay? Before that, what customers had to do was, okay, let's train a scikit-learn model and deploy it on one endpoint, or let's train a Spark model and deploy it on another endpoint. And so they had multiple endpoints, so extra cost probably, and then they needed some high-level API to invoke those prediction APIs in sequence. So plumbing, and we don't like plumbing. So now it's all deployed on one endpoint, and so you call one API, and that API will trigger the whole pipeline. Okay, so if you need to do pre-processing, prediction, post-processing, etc., you can get it done. And this works for real time, so online predictions with HTTPS, and it also works for batch transform. Okay, so you can run batch predictions at scale with your pipeline. So let's look at a quick demo. And this one uses scikit-learn. Okay, so let's skip that stuff. So we're still working with that abalone data set. Okay, we're obsessed with shellfish today. So download the data set from the web. CSV file, okay, this is what it looks like. So, that categorical feature, the sex, male, female, infant, and then numerical features, and the last number is the number of rings. Okay, so it's the target value we're trying to predict. Okay? So, upload the data to S3, because it needs to be there. And then we're going to use a scikit-learn script, just like we used a Spark app to do feature engineering on that data set. And then we're going to do pretty similar things. So that's the scikit-learn code. Okay, we can see obviously the same columns. Let's take a look at the actual work we're doing. So loading the data set here. Okay. Let's try to keep everything on the screen. So what are we doing here? So first, we're dealing with the numerical features. So we're dropping sex, because sex is not a numerical feature, right? It's a categorical feature. And we define a pipeline with two steps. So one inputter, and this will fill missing values. Okay, so if one of those samples has a missing value, scikit-learn would use the median value for that column to replace it. Okay, and then it applies a standard scalar, which is just normalization, just basic normalization on that column. Okay, so that's one tiny pipeline for numerical features, and then for categorical features, again, I have another pipeline where I'm using a simple inputter again to replace, to fix missing values. So in this case, if one of the lines has no sex, we'll just use the missing word, the missing string to replace it. Okay. And then we use one-hot encoding, just like we saw before, because we want to get rid of strings. We want categorical features. Okay, so we have three possible values, male, female, infant. So we'll end up with 3 dimensions. 2 of them will be set to 0. 1 of them will be set to 1, according to the actual sex. Okay. Then I use a column transformer to merge the two transformers above. Okay, so the numeric features and the categorical features, and then I train. Okay, so you see it's it's scikit-learn this time, not Spark, but it's very similar. Okay, it's a simple data set, so there's not a ton of work you can do on that data anyway. Okay, so this will do the feature engineering part. okay? And the rest is just utility functions. So I'm going to train this thing on SageMaker, so I use the scikit-learn estimator, passing my script, and training this on C4XL, okay? So what I'm going to get is a model that has been a model that's able to pre-process my training set, okay? Which is what I do here, okay? Okay, but that's just one step, okay? That's just the feature engineering. Then I want to train my my actual machine learning model, okay? So what I'm going to do is I'm going to batch transform my training data, okay? Because I want my initial training data to be featured engineered, and I'm going to train my actual machine learning model on that feature engineered data, okay? So this is why I need to do batch transform, okay? And I'm going to load that transform data set and train my machine learning algo, okay? And in this case, I'm using linear regression because from those engineered features, I want to predict the number of rings, okay? So I want to predict the numerical value. So again, I use the estimator object pointing at the linear regression algo, a built-in algo in SageMaker. I'm going to train on one M4-2XL instance. And I need to set the hyperparameters for linear regression. So I've got 10 features, okay, engineered. I'm using the regressor mode because, again, I want to do linear regression. And that's about it, okay? I define where the pre-processed training data is, and then I train, okay? So the important thing to understand is I am not training on the initial data set, okay? I am training on the engineered data set, the data set that has been fixed or modified by the scikit-learn script. Okay, so I transfer a bit, fine. And now I can simply create my SageMaker pipeline by calling that pipeline model API and defining the different models that constitute the sequence. Okay, so first, the raw data needs to go through the scikit-learn model to be featured engineered, okay? And that data will automatically then go through the linear regression model to predict the number of rings for that shellfish, okay? So those two models get the job done. And as you can see, I can then deploy the pipeline just like I would deploy a normal model. Okay, so those two models constitute a single unit, and they get deployed to one C4XL instance. Okay? And then, I can predict, just like I would predict usually. So take some data, create a predictor object, and just predict. Okay? And in this case, this shellfish has between 9 and 10 rings. Okay? And if we look at the SageMaker console here, okay, we can actually see, so we see the endpoint that is being used to predict. I can see the URL, etc. Okay? And if I look at the training job that was used to build the endpoint, need to go down a bit. Where is it? Oh, sorry, that's the wrong one. Let me try that again. Model name, yeah, that's the one. Okay, I can see so that model, that pipeline, is really two containers, the scikit container and the linear learner container, okay? Again, deployed as one single unit, okay? So this is another way to deal with pipelines. If you are already using Spark and you want to do a little better at training and predicting, etc., you can export to mleap and then go to SageMaker. Or if you're not using Spark today, and if you're just dealing with multiple endpoints and that's not practical, then inference pipelines are a great solution, a much easier solution to this. Okay? So if you want to get started with this, always the same URLs, the SageMaker URL for all information on SageMaker, and of course the examples, the notebooks on GitHub, and we have some examples for mLeap, and we have some examples for Cyclone as well, so those will get you started. And again, my blog on Medium, where you'll find a lot of SageMaker content. All right, thank you very much. Again, if you want to stay in touch, if you want to try it and send me feedback, you can do that on Twitter or LinkedIn. I'm pretty easy to find. I love to hear about your stories and try to answer your questions. Thank you very much for, thank you. I hope this was useful, and have a great evening. Thank you very much.